Hi everyone, this will be lecture 5 on 3 dimension, and today we are going to discuss a very important equation of plane. The first concept that we are going to discuss is equation of a plane in normal form. Let us consider a plane ABC which can be denoted as pi, and let d be the perpendicular distance from origin to this plane, and ON is a normal, that means ON is a normal factor to this plane, and P is any point. We are considering a point P, arbitrary point P with coordinate x, y, z, and the position vector of P as R. Okay, we can start, first we'll just try to derive the equation of the plane. So we can start with this important points. Let D be the perpendicular distance of plane pi from origin. If ON is, so in case that ON is a normal vector to this plane, if ON is a normal to the plane, and we'll consider an unit vector along ON, and n cap is a unit vector okay, n cap is a unit vector along ON, then so how can you write ON? So that perpendicular distance is given as D. Okay, D is the perpendicular distance. That means the perpendicular distance ON will be D, and we are considering an unit vector along ON. So therefore ON can be written as D and cap. Now the position vector, already have mentioned that position vector of P is R. So therefore this NP, this vector NP obviously will be perpendicular to ON. Okay, so we can use this next space. So let the coordinates of EB x, y, z with position vector R. So now in case if we draw the figure once more here, it will be more easy for us to understand. Okay, so just draw the plane. This is the plane ABC. This is the plane ABC, and say this is ON, normal to this plane, and let us consider a point P which is an arbitrary point, and we will join this. Okay, and this is R, and this is the perpendicular distance from O to the plane is D, so this is the perpendicular distance, right? And now we can just move to the previous page. Okay, so ON, vector ON can be written as D and cap. Now this ON is perpendicular to the plane, therefore naturally this ON will be perpendicular to NP. So yes. Now NP dot, since ON is perpendicular to the vector NP, so their dot product is 0. So NP dot ON is equal to 0. So this implies we can just use the triangle law of vector addition to get the value of NP. Yes, this is right. Now we just find the value of np. So if you use the triangle of addition in triangle ONP, we can just write ON plus NP is equal to OP. So therefore NP can be written as OP minus ON. OP factor minus ON dot ON. Now, what is OP? OP is vector R, and ON can be written in terms of D. This is D and cap dot, this is D and cap equal to 0. And we know that D is not equal to 0, so you can actually remove D from there. So if you cancel D, so and we'll just take the dot product of R minus D and cap with n cap. So it will be, first term will be R dot n cap minus D is there. This D we have cancelled it, and we'll just use the dot product between these two unique vectors, that is n cap dot, this is n cap dot n cap equal to 0. So this is equal to 1. So we get R minus n cap. So D you can write this side D. Fine. So finally we got the vector equation of the plane, which is a normal equation of plane in normal form, that is R dot n cap equal to D. Fine. A very simple steps to derive the equations. Now next steps, what I'm going to do is, from this we are going to derive the Cartesian form. So let's move to next phase. Okay, so Cartesian form. Okay, we'll just first start with the vector form. So vector form is R dot n cap equal to D. Fine. R cap. So now what is R? R is the position vector of, what is R? R is the position vector of P, and we know the coordinate of P is x, y, z. So therefore R can be written in terms of the coordinates, that is x, y, z. So here R is equal to x I cap, y j cap, and z k cap. This is R. And in case element are the direction cosine of this vector, unit vectors, then n cap can be written as L I cap, M j cap, and k cap. What is element? Element are the direction cosine of the vector n cap. Okay. Therefore, which is marked, this is 1. Therefore, 1 implies, okay, R dot. So if you take the dot product between R and n cap, if you take the dot product, so you get Lx plus My nz and equal to T, which is a very simple form and very important equation of plane. Okay, so this is the equation of plane in Cartesian form, right? So this is theory 1, and I will just move to next concept. So what is the next concept? That equation of plane perpendicular to a given vector and passing through a given point. Fine. So let us just think on this particular point, that a plane perpendicular to a given vector. First let us discuss about that, right? So how many plane we can think of when vector will be perpendicular? So for that we can just refer to this particular figure. So these are some parallel planes, and this vector n cap is perpendicular to each of them, right? So therefore a vector can be perpendicular to infinitely many planes. But now we are to discuss a plane which is unique, right? For that, this particular information that a vector is perpendicular to a plane, so it's not sufficient, because if a vector is perpendicular to a plane, so we can't define a plane uniquely. So there does exist infinitely many planes where the vector n will be, or any vector will be perpendicular. Okay, now we have given one more information. What is the information? That equation of a plane perpendicular to a given vector, and most important is this, is also passing through a given point. So when you take these two informations, that a vector is perpendicular to a plane. Apart from that, the plane passes through a unique point. So in case if I again refer to the next figure, yes, right? So say this, we can take any one of the plane. Say this vector is perpendicular to this plane, and we can take a point there. Say it is a point P, x1, y1, z1. Now since we know that in space this point is a unique point, so and this vector is perpendicular to the plane. Apart from this, say this is plane pi 1. So this plane also passes through x1, y1, z1. Therefore this pi 1 is a unique plane. So these two informations are given. So we need to derive the equation of this plane. Let us consider that the plane is pi, right? Now, apart from this plane passes through a point, fixed point A. Then we can take the coordinates of A as x1, y1, z1. Now, this vector n is a perpendicular to this plane. Now, P is any arbitrary point on the plane with position vector r. Now, these other informations are given to us. So based on that, we need to derive the equation of the plane. So initially, we just note the few important points. What is given? Okay. Let the plane passes through. Passes through a point A. Passes through a point A whose position vector is A, and let P be any point on the plane, and let P be any point on the plane, and or you can just write let P be any point on the plane with position vector R. Okay, so A is a fixed point with position vector A, and P is any arbitrary point with position vector R. And we just can move to, yes, we can just move to this. So we don't need this right now. Okay, and let vector n is perpendicular to the plane. So in case if we just draw the figure once more, so it will be easy. Okay. So just draw this once more. Okay, so this is a fixed point A. This is a fixed point A with position vector A, and this is point P with position vector I. Okay, this is position and say this is a vector and which is perpendicular to the plane. Okay, which is perpendicular to the plane. Let n is perpendicular to the plane. Now. Okay, yeah, so just take this figure. Look, now this point P will be lying on this plane, right? Okay, if and only if this vector AP will be perpendicular to n, right? So now we can use this condition. I'll just repeat that concept, that this point P will be lying on this particular plane if and only if that AP vector dot n, that means this AP will be perpendicular to the vector n. So we can use this concept. Yeah. So therefore AP dot n is equal to 0. So that already I have just mentioned that AP. Now this AP we can just find out from the triangle law of addition. So if you use the triangle law of additions, OA plus AP equal to OP. So what is the value of AP? AP is OP minus OA. Right? AP is OP minus OA dot n equal to 0. Now what is OP? OP is A. This OP is vector R minus A dot n equal to 0. So which is the vector equation of the plane? Okay. Well, if the plane passes through a fixed point A and is perpendicular to a vector n. So just can revise the concept once more. What is given? That let the plane passes through a point A. So these are the points. If you need to write a derivation, so initially these points you need to write. Let the plane passes through a point A, right? Whose position vector is A. So we are assuming let the position vector of the fixed point as A. Let P be any point on the plane which position vector R. So P is any arbitrary point, okay, arbitrarily chosen point, and generally the point which arbitrarily chosen is taken as P with position vector R. Okay, so these are the very common symbol. Right? P be any point on the plane with position vector R. So let's move to next page. Fine. Let n is a perpendicular to the plane. Say this n is perpendicular to the plane. Now A is a point. Now this plane is passes through a point A. Now we are taking a point P. Now in case the P lies on this plane, so this AP will be lying on this plane, and therefore AP dot n, right? AP dot n will be equal to 0 because AP will be perpendicular to n. AP dot n. So the race points are very simple. AP, which is can find out the vector AP with the help of this triangle, with the help of the triangle law of addition, and thereby we got this equation of vector equation of the plane pi. Okay, which is very important equations. It has got lots of applications. Okay, now we with the help of this we are just going to form, right? We are going to, yes, we will take this page only. With the help of this equation, that is R minus A dot n, okay, equal to 0. We'll just mark this is equation 1. With the help of that, we'll find the Cartesian form. Okay, so you can use this space, Cartesian form. Okay, Cartesian form. Okay, to derive the Cartesian form of equation of the plane, right? And this R, we know this R can be written in terms of the coordinates, and we know that this is an arbitrary point. We take the coordinate of P as x, y, z, and we can just take let R equal to x I cap, y j cap, and z k cap. So you can take R as, in case if we take the coordinate of P as x, y, z, and R can be expressed in the form of the x I cap, y j cap, and z k cap. Now we know that this A, similarly this vector A can be written in terms of x1 y1 z1, x1 I cap, y1 j cap, and z1 k cap. Okay, now we need to express this the vector which is perpendicular to the plane. Let ABC, okay, let ABC are direction ratios. ABC are direction ratios of n. So if ABC are the direction ratios, then the vector n can be written in terms of A I cap, B j cap, and C k cap. Okay, we know that if we know the direction ratios, then we can obviously express a vector, okay, in terms of the direction ratios A I cap, B j cap, and C k cap. So one implies now R minus A. First R minus A. So if you use this R minus A, so we'll get x minus x1 I cap, then y minus y1 j cap plus z minus R minus A. You subtract x I cap minus x1 I cap. You take I cap common, so you'll get x minus x I cap. Similarly, you'll get y minus y1 j cap and z minus z1 k cap. Fine. So R minus A will give us these expressions. Dot. Right? Dot will write these expressions, that is A I cap, B j cap, and C k cap equal to 0. Now we are going to use a dot product between these two vectors. If you use a dot product, so get only I dot I. This will get the terms that I dot I, j dot j, and k dot k. Remaining all the terms will be 0. So just get first term as x minus x1 into A. So if we write in a standard form, this is A x minus x1 plus D, okay, B y minus y1 plus C, and z minus z1 equal to 0. So which is the Cartesian form of equation of plane. Okay, so this is another very important equation of plane. And what is x1, y1, z1? If you can just think about these equations, and this x1, y1, z1, these are the coordinates of the fixed point, right? And what is ABC? ABC are the direction cosine of the vector which is normal to the plane. So please try to derive this equation, go through this one, the steps, and try to derive these equations, and try to solve questions using this formula. So when you will start applications now, you will easily remember the theory part. Okay. So next, we'll just move to the last concept. Yeah, we'll just move to this particular concept. What is the concept? That equation of a plane passing through three non-collinear points. Okay, this is another very, very important theory. Okay, for your class, right? Let us consider three non-collinear points. Let us mark this one. This is R, S, and T. Right? Let us consider R, S, T are three non-collinear points. Now, we need to find an equation of plane, right? Equation of a plane which passes through these three non-collinear points. We know that if the points are non-collinear, right? We can uniquely define a particular plane, right? We can just derive these equations of the plane with the help of this information, and we know that through these non-collinear points, one and only one plane can be considered. Now, before that, let me explain another very important point, right? So, since RST, since this plane passes through this point RST, so RS is a vector which is lying on this plane, and RT also a vector which is also lying in this plane. That means Rn and RT are in the plane. Now, therefore, RS cross RT, this is RS cross RT, will be a vector which will be perpendicular to this plane. So therefore, this RS cross RT is a vector which is perpendicular to the plane. Okay. Now, let's start the theory like that. Plane R, S, T, be 3 non-collinear points, which will mention about the position vector, which position vectors A, B and C respectively. Okay, C respectively. Let PB, we'll consider any arbitrary point P on the plane. Well, let P be any point on the plane which position vector R. Position vector R. Now, to derive this particular equation, okay, we'll be using the previous concept, that is theory 2. We are going to use it. I'll just write an equation, that is R minus A dot n, which is the equation that just now we have discussed. Okay, this is the equation of a plane, and where this vector is normal to the plane. Apart from that, the plane is passes through a fixed point. Now, we got, with the help of this concept, that is Rs and Rt, these two vectors are lying on this plane, and therefore Rs cross Rt is perpendicular to the plane. Therefore, we got a vector which is perpendicular to the plane. So, you can compare this one. So, for this case, what is n vector is Rs cross Rt. Now, in case we know that this plane is passes through R, so if you consider this in place of, here in this case, the fixed point was A. Here, let us consider a fixed point as R, with position vector is A. So now, using this concept that this plane, forget about, at this moment, just think about R. This plane is passes through R, okay, with position vector A. Apart from this, that Rs cross Rt is perpendicular to that plane. But therefore, these 2 points are sufficient to derive the equation of this plane. I hope this point is clear to you. This is the most important point. So, and therefore, to derive this one, you need to derive these equations, right? So, these are given in a very systematic and sequential order in the NCERT text. Okay, so what I'm going to do is, so try to, therefore, if you could follow those points, so we can just directly write the equation of the plane. Okay. Therefore, the equation of the plane, can be written as R minus A. Exactly similar way, R minus A, because the plane is passes through this point, a fixed point. You can consider a fixed point as R, right? If we consider the fixed point as R, because the plane is passes through R S T. So any one of the point you can consider. Let us consider the point R with the position vector A. So R minus A. Now next, what you should know, we should get a vector which is perpendicular to the plane. So Rs cross Rt is a vector which is perpendicular to the plane. So you can just write Rs cross Rt equal to 0. So which is the required equation of the plane? Very, very simple steps. So since we are using this concept, so it's becoming more simple. Rs cross Rt equal to 0. So we can just simplify a little more than this. So this implies we'll just remain we'll keep R minus A as it is. Now you can just write a value of Rs. Okay, if we just write a value of Rs you can just write. So we know that Rs, what is the value of Rs by triangle of addition? OR, I'll just write these points, that is OR plus Rs equal to OS. Therefore, RS, this RS can be written as OS minus OR, right? OS minus OR. So what is OS? OS is equal to B. B minus OR. OR is A. Fine. So cross RT. So directly you can just write the value of RT. So from this triangle ORT, RT can be written as OT minus OR. That is, what is OT? OT is vector C minus the initial vector, that is vector A. So you can just write C minus A, okay, equal to 0. Yes, this is a very important equation. That is R minus A dot B minus A cross C minus A equal to 0, which also can be expressed in terms of scalar. This is already expressed in scalar triple product, okay? So which is the Cartesian form of, which is the vector form of equation of the plane, right? Vector form. Now, based on this, we are going to establish, or we are going to derive the Cartesian form of equation with the plane, right? To derive the Cartesian form, what do you need? So let's see the steps. What do you need? So here, if we see that, so what are the terms are involved? R, what is R? R is the position vector of R. Yes, R is the position vector of point P. So you should know the coordinate. Coordinate of P always can be taken as x, y, z. Now we need to take the coordinates of the other. What are the other terms are used? A. What is A? A is the position vector of R. So we'll take the coordinate of R, S, T, and P. So to derive the equations, we need to assume the coordinates. So Cartesian form. Okay, Cartesian form. Let the coordinates of R, S, and T be. So we'll take the coordinates of R, S, and T. Let the coordinates of R, S, and T be x1, y1, z1, x2, y2, z2, and okay, T be x1, y1, z1, x2, y2, z2, and x3, y3, z3 respectively. Okay? Yes. Right? Let the coordinates of R, S, and T be x1, y1, z1, x2, y2, z2, and x3, y3, z3 respectively. Let the coordinates of P be x, y, z. So let me just write the vector equations. Let's get back to the particular equations. What is the equations? That is R minus A, B minus A, C minus A. Fine. R minus A. This is R minus A. RS. RS you can write as B minus A, and RT you can write as C minus A. Okay. I'll just note down this equation there. Okay. R minus, right? R minus A dot, okay, B minus A cross C minus A. Fine. This is a vector equation of the plane B minus A and C minus A. Now first we'll write, express all this, the position vector in terms of the coordinates. First we'll start one by one. Therefore R can be written in terms of x, y, z. So R can be written as x I cap, y j cap, and j k. Next I'll write A, position vector of R. What is the coordinates of R? Coordinates of R is x1, y1, z1. Therefore A can be written as x1 I cap, y1 j cap and z1 k cap. Similarly, b can be written as x2 I cap, y2 j cap and z2 k cap. And this one, c can be written as right. C can be written C can be written as, because c is a position vector of the last point, that is t. And what is the coordinate of t? x3, y3, z3. So can be written as x3 I cap, y3 j cap and z3 z3 k cap. Fine. Okay. It seems like when we write all this, it seems that it's very long steps. In fact, these steps are, you can just reduce the steps also. Okay, you can just reduce these steps, and you can just with the help of this one, all right, with the help of this particular equation, that is vector equation of the plane. Okay, and you can just minimize the steps. But since these are the steps I have written for everyone. Okay, in case this particular topic you have not studied, so you need to know, like in case the derivation also comes in exam also, you should know how to write. Fine. So therefore it's very important. So to write, and apart from this, from your point of view, you need to note down all these points. Okay, so that you find it very comfortable the moment. But I will suggest you that after listening to this explanation, you can try the derivation by yourself. Okay. Now we'll just derive it. Of course, it's done. Okay. So to derive this most important information, we need this. And this one we can write. If we go back to this one, it will be easy for us to understand, right? This r minus a. Alright, I'll just simplify this. This r minus a can be written as, from the figure, I'll just show you. Okay, yes. Okay, r minus a. R minus a can be written as rp, right? Because r minus a is rp. Then b minus a is rs, and c minus a is rt. So if we change to, yes, this is rp. Okay, dot. This is b minus a, b minus a, right? B minus a. All you can write in terms of r. This is rp, this is rs, rt. Okay. rs, rt. Right? Yes. You can convert this one. R minus a we can write in terms of rt. B minus a, nothing else. This is rs and this is rt. Okay, fine. Now just we'll write what is rp. First we'll just write now what is rp. Okay, rp. A, B, C. I'll just go through the, yes, rp. Now rp means, right, rt. Right? Rp means r minus a. So r means what? The position vector of p. So to find rp, so you have to find rp, right? So what you need to do is that rp means this is r minus a. So r means this is x I cap, y j cap and z k cap. And a means that is x1 I cap, y1 j cap and z1 k cap. So in fact, if you write rp, you can write in the form of x minus x1 I cap, y minus y1 j cap and z minus z1 k cap. So we'll be using yes. Okay. So okay, now rp. Rp is r minus a. So r minus a. So just subtract x minus x1 I cap, then y minus y1 j cap and plus j. Okay, this is yj and this is, okay, I'll just write it. Yeah, this is j k cap, right? This is z k cap. So z minus z1. This is z minus z1 k cap. So say you can just mention, right? Say this is 1. Fine. This is 1. Now next b minus a. B minus means rs. So rs, we'll find out rs. What is rs? B minus a. B minus a. Right? So if you subtract b, what is b? This is x2. x2 minus b minus a. This is x2 minus x1 I cap. y2 minus y1. y2 minus y1 j cap. And z2 minus z1. z2 minus z1 k cap. Assume this is 2. Fine. Now rt. Right? Okay. Next one is rt. Fine. Rt means c minus a. C minus a. Right? This is c minus a. Rt means c minus a. C minus a is this. Okay. C means x3 minus x2. We'll just write in this way. That is rt. Okay. C minus a. This is x3 minus. Fine. x3 minus x2. C minus a. Fine. No, this is x3 minus x1. It's not x3 minus x2. Fine. Yes. Okay. So this is x3 minus x1 I cap and y3 minus y1 j cap, and this is c minus a. C is this one. This is c and this is a. This is a. So x3 minus x1 I cap, y3 minus y1 j cap, and z3 minus z1. z3 minus z1 k cap. This is 3. Okay. So we'll just compare the steps. Rp first. Rp, that means Rp means r minus a. R minus a. Okay. R is x, y, z. So first term is obviously x minus x1. This is done. Then rs. Rs means b minus a. B minus a means x2 minus x1. x2 minus x1. Similarly, we got the other two terms, and the third term is rt. C minus a. C minus a means you need to subtract x3 minus x1 I cap, and you will get the other two terms. Fine. So this, the three informations you got. Okay, three important terms you got, and based on that, we can write the Cartesian form equation of the plane. Now we know that rp dot rs cross rt. This is written in the form of scalar triple product. So this also can be written as, this also can be written in the form of rp. Okay, this is can be written in the form of, I'll just write this one, scalar triple product. That is rp, okay, dot rs, okay, comma beta. This is the form of writing scalar triple product. Rp comma rs comma rt equal to 0. And we know that if three vectors are written in form of scalar triple product, right, then this vector can be expressed in the form of, right, in the form of determinant, right? How do you write this one in the determinant form? So determinant form can be written in the form of like that. That is a1, b1, c1. So what is a1, b1, c1? a1, b1, c1 is the scalar component of the first vector, that is the first vector. Fine. So anyway, if these three vectors is a, b, c, if we simplify a little more than that, say these three vectors, one you term as a, another is b, another is c, then this can be written in the form of scalar triple product as a, b, c equal to 0. Fine. And if the component of a, that is a, if you write a1 I cap, a2 j cap, a3 k cap, say the component of a is a1, a2, a3, then this, and similarly you express b in the form of b1 I cap, b2 and b3 like that. Similarly for c, then this scalar triple product can be expressed in terms of the determinant. How do you write that? First we write the scalar component of a, that is a1, a2, a3, and next we will write the scalar component of b. Then in case b is expressed in the form of b1 I cap, B2 Jacob, B3 Jacob, then it will come the scalar component of B, that is B1, B2, B3, and similarly the last row will be C1, C2, C3 equal to 0. So we'll be using this concept to write the Cartesian form of equation of the plane, right? So each term we have explained. Now we need to replace this RP, RS and RT in this particular expressions, right? And after that we need to express this one in terms of determinant. So directly, which we can do directly now without actually putting this value. Okay. Therefore, you can just write. Therefore, the equation of the plane. Equation of the plane in Cartesian form is, so just write the equation of the plane in Cartesian form. So just note down RP, RS, RT, okay, equal to 0. So if we express in determinant form, now first vector is RP. What are the scalar component? That is x minus x1, y minus y1, and z minus z1. These are a scalar component. Then RS. So this is the second vector. That is x2 minus x1, y2 minus y1, z2 minus z1. And similarly RT. RT is the last vector. What is the scalar component? These are the scalar component. This is y2, right? x2 minus x1, okay, y2 minus y1, and z. No, this is y3. Fine. This will be y3. This is y3. x2 minus x1, y3 minus y1. This will be z3 minus z1 equal to 0. Okay. So this is the Cartesian form of equation of the plane, right? This is a Cartesian form. So I have already explained you that how we can just write this equation, this particular equation from that equation 1. Okay, when three vectors are written in terms of scalar triple product, right? Scalar triple product. So scalar triple product is expressed in the form of this, and which also can be written as A dot B cross C. Fine. So it's very simple way to express in Cartesian form. Okay. So these are the three theories we have discussed today, and next we'll be discussing 2-3 more theories are there, and we'll just discuss in the next video, and after that we'll just start question answers. Thank you everyone watching for my channel, and in case if you are new, please do subscribe the channel, and don't forget to press the bell icon so that you keep getting the informations or latest videos, updates about my channel. Okay, thank you so much.